What's up, everybody? This is your boy Tech G back with another video to help you successfully pass the CompTIA Security Plus 601 certification exam. So let's get into it. In this video, you're going to learn about cloud architecture components such as managed service providers and managed security service providers, on-premise versus off-premises, fog computing, edge computing, thin clients, containers, microservices and APIs, infrastructure as code, serverless architecture, services integration, resource policies, transit gateways, and virtualization. So let's talk about managed service providers and managed security service providers. So a managed service provider, or an MSP, this is an outsourced third-party company that manages and assumes the responsibility of a defined set of day-to-day management services to its customers. It is a strategic method of improving operations that is commonplace amongst large corporations, as well as small and medium-sized businesses, nonprofit organizations, and governments. An MSP is an organization that can manage your network infrastructure, servers, and in some cases, security devices. A managed security service provider, or MSSP, this provides outsourced monitoring and management of security devices and systems. Common devices include managed firewalls, intrusion detection, virtual private networks, vulnerability scanning, and antiviral services. MSSPs use high availability security operations centers to provide 24/7 services designed to reduce the number of operational security personnel an enterprise needs to hire, train, and retain to maintain an acceptable security posture. Next is on-premises versus off-premises. So on-premises, this is the software and technology that is located within the physical confines of an enterprise, often in the company's data center, as opposed to running remotely on hosted servers or in the cloud. By installing and running software and hardware located within the premises of the company, IT staff have physical access to the data and can directly control the configuration, management, and security of the computing infrastructure and data. And off-premises is simply nothing but using a cloud provider and not your own. Next, we have fog computing, and this is also known as fog networking. And this is an architecture that uses edge devices to carry out a substantial amount of computation, also known as edge computing, storage and communication locally and routed over the internet backbone. Fog computing describes a decentralized computing structure located between the cloud and devices that produce data. This flexible structure enables users to place resources, including applications and the data they produce, in logical locations to enhance performance. The structure's goal is to locate basic analytic services at the edge of the network, closest to where they are needed. This reduces the distance across the network that users must transmit data, improving performance and overall network efficiency. Next, we have edge computing, and this brings computation and data storage closer to the devices where it's being gathered rather than relying on a central location that can be thousands of miles away. This is done so that data, especially real-time data, does not suffer latency issues that can affect an application's performance. In addition, companies can save money by having the processing done locally, reducing the amount of data that needs to be processed in a centralized or cloud-based location. Edge computing was developed due to the exponential growth of IoT devices, which connect to the internet for either receiving information from the cloud or delivering data back to the cloud. And many IoT devices generate enormous amounts of data during the course of their operations. Let's talk about a thin client. So this is a simple, low-performance computer that has been optimized for establishing a remote connection with a server-based computing environment. The server does most of the work, which can include launching software programs, performing calculations, and storing data. This contrasts with a fat client, or a conventional personal computer. And the main benefit of a thin client setup is there is improved maintenance and security due to central administration of the hardware and software in the data center. And here are some of the features of a thin client. So you have basic applications, and the benefits are it can perform basic office procedures such as web browsing, word processing, and spreadsheets. It can meet the minimum requirements for using selected operating systems, and the benefits are it can run the OS at basic performance levels. You have network connectivity, and the benefit is it can provide fast network connection because the server handles most computational tasks. And then it it has account settings, and the benefits are it can offer secure authentication. Let's talk about containers. So containers are lightweight packages of application code put together with dependencies such as specific versions of programming language, runtimes, and libraries required to run software services. Containers contain all of the necessary elements to run in any environment. In this way, containers virtualize the operating system and run anywhere, from a private data center to the public cloud or even on a developer's personal laptop. Containerization allows development teams to move fast, deploy software efficiently, and operate at unprecedented scale. Containers are often compared to virtual machines, but the main difference between a container and a virtual machine is a virtual machine can virtualize an entire machine down to the hardware layers, while containers only virtualize software layers above the operating system layer. And here's a handy dandy little graphic to help you visualize the differences between virtual machines and containers. And you can see the Docker engine in this picture in reference to containers. Understand that Docker is one of the most popular companies out there that produces containers. Next, we have microservices and APIs. So microservices, these are architectural and organizational approaches to software development where software is composed of small independent services that communicate over well-defined APIs. These services are owned by small self-contained teams. Microservices architectures make applications easier to scale and faster to develop, enabling innovation and accelerating time to market for new features. An API, this is the connection between computers or between computer programs. It is a type of software interface offering a service to other pieces of software, in contrast to a user interface which connects a computer to a person. An API connects computers or pieces of software to each other. They are not intended to be used directly by a person or the end user other than a computer programmer who is incorporating it into software. Next, we have infrastructure as code. So infrastructure as code, this is the managing and provisioning of infrastructure through code instead of through manual processes. With infrastructure as code, configuration files are created that contain your infrastructure specifications, which make it easier to edit and distribute the configurations. It also ensures that you provision the same environment every time. By codifying and documenting your configuration specifications, infrastructure as code aids configuration management and helps to avoid undocumented ad hoc configuration changes. Version control is an important part of infrastructure as code, and configuration files should be under source control, just like any other software source code file. Deploying infrastructure as code also means that it can divide an infrastructure into modular components that can then be combined in different ways throughout automation. And two elements you need to be concerned with in regards to infrastructure as code are as follows. You need to know about software-defined networking. And this is an approach to network management that enables dynamic, programmatically efficient network configuration in order to improve network performance and monitoring, making it more like cloud computing than traditional network management. Software-defined networking is meant to address the fact that the static architecture of traditional networks is decentralized and complex, while current networks require more flexibility and easy troubleshooting. Then you also need to know about software-defined visibility, and this is similar in concept to software-defined networking, but is designed and optimized to provide intelligent visibility of what's happening across an organization's network or in the cloud. Next, we have serverless architecture. So this is an approach to software design that allows developers to build and run services without having to manage the underlying infrastructure. Developers can write and deploy code, while a cloud provider provisions servers to run their applications, databases, and storage systems at any scale. Servers allow users to communicate with an application and access its business logic, but managing servers takes considerable time and resources. Teams have to maintain the server hardware, take care of software and security updates, and create backups in case of a failure. By adopting serverless architecture, developers can offload those responsibilities to a third-party provider, enabling them to focus on writing application code. Next, we have services integration. So cloud services integration. This is a series of tools and technologies used to connect different systems, applications, code repositories, and physical or virtual network infrastructure to allow real-time exchange of data and processes. One of the main goals of cloud service integration is to break down data silos, increase visibility, and improve business processes. These service integrations are crucial for most organizations needing to share data amongst cloud-based applications. Next is resource pools. So resource pools involve creating, assigning, and managing rules over the cloud resources that systems or applications use. Resource policies are also often created to make sure the resources remain compliant with corporate standards and service level agreements. Cloud service providers offer different solutions that help maintain good cloud usage governance by evaluating deployed resources and scanning for those not compliant with the policies that have been defined. Next, we have a transit gateway, and this is a network transit hub that you can use to interconnect your virtual private clouds on an on-premise network. Transit gateways can also be used to connect cloud-hosted applications to software-defined wide area network devices. And then we have virtualization. So virtualization, this refers to the act of creating a virtual rather than actual version of something, including virtual computer, hardware platforms, storage devices, and computer network resources. Virtualization allows for standalone computers to run multiple operating systems at the same time while using the same hardware resources. And two concepts you need to be concerned with are as follows when it comes to virtualization. You need to be concerned with virtual machine sprawl. And this is a phenomenon which occurs when the number of VMs connected to the network exceed the network's capabilities. VM sprawl often happens when there is freedom to provision instances because of a lack of proper implemented policies regarding provisioning. And then you need to know about virtual machine escape. And this is a security exploit that enables a hacker to gain access to the primary hypervisor and its created virtual machines. VM escape enables a user to escape from the guest operating system boundary created and managed by the hypervisor to gain access to the top tier virtualization layer. All right, so that was my class on cloud architecture components, where we talked about things such as managed service providers and managed security service providers, on-premises versus off-premises, fog computing, edge computing, thin clients, containers, microservices and APIs, infrastructure as code, serverless architecture, services integration, resource policies, transit gateways, and virtualization. Now, if you felt like you've gotten something valuable from this information, go ahead and hit the like button, share button, drop a comment, but most importantly, subscribe to this channel. Also, go check out my website, Technology G, so that you can get read up on the latest and greatest to help you successfully pass the CompTIA Security Plus 601 certification exam. And until next video, ladies and gentlemen, peace.